This is AP Computer Science with the Arupe Virtual Learning Institute. My name is John Maxwell. Today we're going to go over loops, or what the module is entitled Control Structures. Control, because it decides what lines of code are going to be executed, and it also controls how many times they would be executed. So there's two main forms that we're going to look at this week. One is called a for loop, highlighted on line 24 here. You'll have the file. The for loop is constructed of three statements. Notice the semicolons between the components. Also notice, like other block statements that begin with a set brace, there is no semicolon there. Everything in between the braces is what gets executed each step of the loop. So let's start. This loop begins when x is 0. It asks the question, is x less than or equal to 20? And it will execute the code within the braces. In this case, raising x to the power of, 2 to the power of x. Then it will increase x by 1, so x after the first iteration becomes 1, and it will execute the math statement within the braces. X then becomes 2, executing the statement within the braces, 3, 4, 5, 6, and so on until x becomes 21. As soon as it exceeds the control condition or the stopping condition, it will execute the next statement after the loop block. So let's look at the basic components of loops. All loops, regardless of type, have a start that would be x equals 0, have a stop that's evaluated x is less than or equal to 20. As long as that's true, it keeps running, but it stops when x becomes 21, a stopping condition, and it has a change condition. In order to reach 21, x has to go up by some value, in this case x plus plus by 1. Note it can go up by 2, x equal x plus 2 plus 3. However you want to iterate, you can change and alter the change expression. So there's 3 parts to every loop: start, stop, and change. And that's important to remember as a basis. In class, someone asked, can they count down? Yes. Can they count to the middle of, say, a string? Yes. And so you can alter both the way the loop counter variable, in this case x, changes, and you can also alter how far or when, under what conditions the loop would continue. So we have a duplicate loop down here. It's called a while loop, and it still adheres to the 3 requirements: start, stop, change. I used a different variable called y as the loop counter variable, also known as LCV abbreviated, and it does the very same thing as the for loop up ahead, which is y is less than or equal to 20. It'll output math 2 raised to the y power, and most importantly, and most often forgotten by anyone, and even at the beginning level, is y plus plus. So within the body of the loop, it needs to progress towards the stopping condition. So y begins at 0, it ends at 21, and it progresses by 1. Again, it can progress by any value, decrease by any value. So you can go from 20 to 0 if you want. The difference is, in this case, none, but In most cases, people use a while loop for indeterminate conditions like, would you like to continue? And the user would enter yes. Or the while loop might trap you in a endless cycle as long as you're unable to type your password. Okay, so these are examples of indeterminate. They are loops that need some user input in order to complete. Okay, so a while loop is more frequently used in that condition, although it can be used to count from 0 to 20. A for loop, however, is wonderful at counting, okay, and is most often used for that. And we're going to look at an example of that. So let me just run this and show you what the powers of 2 are. Harken back to our first unit. Okay, they're outputted twice because I have both types of loops. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 squared, 2 to the third is 3, and so on and so forth. Here we go with the powers of 2 once again. Let's go back to binary. So I'm just going to put in a comment here so that we're not running this, and we'll put in a comment there. No, we'll put in a comment that way. Well, no, we won't that way. Okay, I think that works. What we want to look at here on lines 8 through 13 is, well, 8 through 12, is an application of a for loop with a string. And I have a string called me along, pardon me the joke, Lollapalooza, and what we're going to do is iterate through the string starting at index 0 and going up to but not including me along dot length. So you can see that the last index in the string is 1 minus the length, so we're going to say I is less than the length, and we'll go up by 1. And in this case, we're doing something really boring, which is to take a substring of each character one by one and put 4 spaces after it. So let's run it and take a look. And you can see down here we have it spelled out with each letter 4 spaces in between. And so a for loop here is a good application for processing a string. And this is really ridiculous, okay, but you might want to process a string for other reasons, okay, find and replace or other parts like that. And while we're at it, I'm going to look at a palindrome. Okay, so a palindrome, I'm just gonna comment this out to there, is something that's spelled the same forward and backwards. And so we have common examples like the name Bob, or the word Madame, M-A-D-A-M, is forward and backwards. Race car, that's a famous one, and the most famous of all, because it's in my program, is something aman, a plan, a canal, Panama. Okay, so we're having some kind of drawing with the Panama Canal. Alright, well, we take the original string and we can go ahead and mark it down to lower. And the reason why is this P is not the same as that P. One is capital and the other is lowercase. So if we convert it all to lowercase, then we are able to properly do a comparison. And then on the other part, okay, we want to get rid of the commas and the exclamation points. And so we have a method down here which you could look at, which is convert to alpha. And we have a string which is going to be returned reprocessed. And we go through this string, original, and ask, is this character caret, okay, a letter or a digit? And caret is another method of string which is not required to be known for the AP exam, but is very handy. And it extracts each char or character, which is what a string is composed of, characters at a particular index x. And what I take that and add it to reprocessed, and in the long run I return reprocessed. So now I have it forward in original without any uppercase letters or punctuation. And now I want to check whether it's the same as reverse. Okay, so let's take a look at this. This returns a Boolean, and we set up a string which is reverse, and we go from original dot length minus 1 downward. Well, it's greater than or equal to 0, I minus minus, and we add that character starting at the last character until the beginning character to a string called reverse, and return reverse dot equals original. The palindrome problem is like constantly referred to in the AP computer science exam in a variety of ways. So what we want to do is just run it and show you, this is what it looks like when it's been processed to lower and convert to alpha, and it says it's true. So let me just change one letter here, a plam, and it's not a palindrome anymore, and it says false. So what it does is compare this string going forward and going backwards. And this is an example of a downward counting for loop, but it's also an example of using the loop counter variable, in this case I, within to access individual indices within a string. And using a for loop is going to be like something that we're really going to focus in on as we bring in advanced topics like array and 2D matrix and other topics like that, including reading from a file. We're going to need loop. It's the workhorse of computing. Now, I asked the class, is it useful to go all the way through the string? What if this was demand? Wouldn't it be better to just say D is not equal to the last letter A and then call it quits? Okay, as soon as we find a letter is not a match. Well, that's what happens here. And let me show you that. Uncalculate that. We'll just switch that. We're good. And I have is palindrome. Let me call that method instead of is pally reverse. And there we go. We're looking at the string again, and we're saying the last character is stored in A, and we're saying if the character at X is not equal to the character at the end of the string, return false. Get out of town right away. If we get all the way through the loop, we'll return true. So let's see. Demand. Whoop. Probably a brace somewhere. Yeah, this residual comment statement false. But the beauty of it is, take a look. It only processes up to the middle. The first, the last, the second to last, the third to the last, the fourth. And when it gets to the length divided by 2, it stops. So while we don't have to really concern ourselves at this level with efficiency, going halfway through the array is twice as good as going all the way through, constructing a reverse string, and then doing a comparison. What happens in the case where most words are not palindrome, this will have a tremendous level of efficiency, okay, by individual character comparison. So that's what I wanted to tell you about that. So I'm going to go back and summarize downward coning for loop example, okay, is what you covered here. We'll go back to here and we'll take this and we'll just comment this out. And here we have a nested for loop. Okay, we introduced this last week and I really regretted it because I didn't want to make this so complex at this time, but let me just run it and show you what it looks like. Whoa, not that way. I think it's, again, a stray comment statement. Okay, so it's a times table. It's the 12, 1 through 12 times. 12 times 12 is 144. Boy, I remember elementary school trying to memorize the times table. Do they still do that with you guys? We had to memorize it with the nuns hanging over our head. Okay, I just couldn't get it in most cases. But 6 was my specialty. Oh, I'm digressing. Okay. Anyways, here's what happens. X starts at 1, and that's fine. It's less than 12. So it goes in and executes the second statement. And y is 1, and it's less than 12, and so it outputs 1 times 1 is 1. And then because, okay, this statement here, this inner loop is not completed, it will go all the way through 1 times 2, 1 times 3, 1 times 4, and output it, okay, before, and it'll have a line feed here so that I move down to the second line, and then it will go and say x is 2, and is that less than 2, and it'll execute the inner for loop completely for each step in the outer loop. Let me repeat that. That's the secret. The inner loop executes completely for each step in the outer loop. Okay, so you may not realize it, but this is happening in front of your screen thousands of times a second. Okay, that's what Hertz stands for, refreshing. And your TV gets refreshed starting at the upper left hand corner, 0 0, that's the first row. Processes the first row just like the ones table. And then it goes to the 2s, the second row, and then it goes to the third row, the third 3 table, 4 table, and then it'll go all the way down to 1084, okay, or some value, 4K, 4,000 rows. Can we believe that, right? 8K, 8,000 rows times how wide, right? That's a lot of processing to refresh each pixel, and that's why they invented the graphic processing unit known as GPU. And then voila, scientists started using the GPU for its advanced mathematical capabilities, and then, okay, AI started using the GPU to develop all those nifty chat GPTs. And so it was all done because this for loop is very inefficient. How inefficient? It's, you know, quadratic. Think about that. The predominant term is n squared. It's 12 times 12. It runs 12 times 12 times this one. So they ask you sometimes, how many times will this loop run? That's it. And that 12 times 12 is quadratic. It's the predominant term in the quadratic equation, n squared. And that is another area of efficiency. We don't have to rate them mathematically. You won't have to do that until you major in computer science in your third level class, which is algorithms. It starts with this class, then goes to data structures, then to algorithms. So you know a little bit more beforehand. And hopefully as a result of watching this video, you know a bunch. And I really appreciated talking to you in class last week. I apologize for a one-day delay in posting this. When I traveled, I forgot to take my charger, and so I had to borrow one, and then it was a slow charger, and then, well, that's my excuse. But thank you for being tolerant. I always appreciate it.